continue the same topic which we are learning from the last 3 sessions, and that is flip-flop. Today we will focus on the circuit diagram of flip-flop. Till today we have seen the block diagram of flip-flops, but in this session I am going to explore the block diagram and we will learn the circuit diagram, which is the actual diagram of any circuit. See, we have seen the block diagram like this. This is J, K, this is gate, this is Q, and this is Q bar. Right? J and K are the input for data, and this is the gate. This is also input line, but this input line is known as gate, and this is the actual output line. Flip-flop is made to store one bit of data, and that bit we will get from Q. Q bar returns the complement. Actually, this is the recap of the session, what we have learned earlier. Flip-flop is a circuit which is used to store one bit of data. Suppose it has 1 inside. Where we will get 1? From Q. This is the actual output. But we have one complement output also. If we need the complement data, then we can get it from here. We will get 0. If the flip-flop has 0 stored inside, then we will get that 0 from Q, and the Q bar will return 1. So this is the actual output line. So this is the recap of the session. And what is the difference between flip-flop and latch? This is J, K, this is Q, and this is Q bar. J and K, Q and Q bar. See, this is flip-flop and this is latch. What is the difference? The difference is that latch has no gate. The gate line is missing. That is why the definition of flip-flop is gated latch is known as flip-flop. This is also one definition of flip-flop. Now we are going to design the circuit diagram of flip-flop. There are 2 possible circuit diagrams for flip-flop. The first possibility using NOR gate. Using NOR gate. This is the most common possibility of circuit diagram of flip-flop. How do we do that? See, we take 2 NOR gate. This is one, and this is another. This is Q line and this is Q bar line. This is input and this is input line. Here I am going to draw the block diagram. Let me make it bit large so that it will be visible to you also, you very clearly. JK, Q and Q bar, and this is the gate. So we have 2 input lines, J and K. This is J and K. We have 2 output lines. This is Q and Q bar. What about gate? This is the I have not completed yet. The output of this will have to go as input to this, and the output of this will have to go as input to this. This is the design for latch. This is the design for latch. Now what change we will make to this, and it will become flip-flop. What we have to do? We have to take one and one more and, right? This is J and this is K. This This is J, this is K, and this is gate G. Now this is the complete circuit diagram for JK flip-flop. Now what do? If we design JK flip-flop using NOR gate, we must note that the truth table of JK will like this: JK output, which we have learned in the last session. But I am going to repeat the truth table of JK flip-flop because today we are going to discuss another design possibility of flip-flop using NAND gate, and the truth table will become different. 0, 0 is known as no change. 0, 1 is known as reset, and 1, 0 is known as set, and 1, 1 is known as toggle. In very simple word, using very simple words, I have explained the design of flip-flop. If the flip-flop is designed using NOR gate, then this truth table is correct. But in the case of another design possibility of flip-flop using NAND gate, this truth table will not correct. So 0, 0, no change in a state. 0, 1, reset a state. 0, 1, reset a state. 1, 0, set a state, and 1, 1, toggle a state. Okay. Now, another design possibility of flip-flop. What do? Just clean the board and draw fresh. See, flip-flop using NAND gate. This is another design possibility. Second, using NAND gate. This is NAND gate, and this is NAND gate. Do the same like we did in NOR gate, and see, right? Now same, take two AND gates. This is J, this is K, and this is gate. This is Q, and this is Q bar. See, when we go for the second possibility of flip-flop design, which is the flip-flop using NAND gate, then we find this truth table is not correct. We need to make some changes. What changes? Zero, zero was no change state in the case of flip-flop of NOR gate. But here, in the case of NAND gate, the 0, 0 will be toggle state, and 1, 1 and 1, 1 will no change state. 0, 1 was reset state in the case of flip-flop of NOR gate. Here in 0, 1 will set state. state.
Finally, 1-0 was set a state in the case of
Last flip-flop, but here reset the state.
if you will compare, what do? You put the truth table of flip-flop using NOR gate and flip-flop using NAND gate, you will find the truth table will totally opposite of each other. Hope you understood the session. Thanks for joining. Take care. Bye-bye.